Muy buenas tardes a todos. Vamos a dar inicio a la mesa de trabajo número 2, que trata sobre el cambio climático ambiental mundial, el desafío para América del Norte. Contamos con 4 ponentes de lujo. Voy a permitirme leer brevemente su currículum. En primer lugar, tenemos al profesor Gordon McBean, quien es profesor de Geografía en la Universidad de Ontario Occidental y director de políticas del Instituto para la Reducción de Pérdidas por Catástrofes. El profesor McBean ha fungido como ministro auxiliar adjunto del Servicio Meteorológico de Canadá y como presidente del Comité Científico Internacional del Programa de Investigación del Clima Mundial. Recibió la medalla Patterson por sus destacadas contribuciones como canadiense a la meteorología y en la actualidad es miembro de la Royal Society of Canada, de la Canadian Meteorological and Oceanographic Society y la American Meteorological Society. Antes de seguir con las presentaciones, quisiera aclarar que la mecánica para esta mesa consistirá, si están de acuerdo nuestros destacados ponentes, en una breve presentación de no más de 12 minutos para dejar tiempo a una brevísima discusión entre ustedes y entre el público. ¿Estamos bien? ¿De acuerdo? Muy bien. Entonces, nuestro segundo ponente es el doctor Víctor Magaña, quien es profesor de Ciencias de la Atmósfera y jefe del Departamento de Meteorología del Centro de Ciencias de la Atmósfera en la Universidad Nacional Autónoma de México. El profesor Magaña es miembro también del panel intergubernamental sobre el cambio climático, al que, como todos ustedes saben, se le concedió el último premio Nobel de la Paz. El profesor Magaña ha conducido diversos estudios sobre el fenómeno del Niño y se ha desempeñado como vicepresidente de CLIVAR, Programa Internacional de Investigación que estudia la variabilidad y la predictibilidad climáticas. Tendremos en tercer lugar al doctor Jorge Soberón, quien es profesor de la División de Ornitología en la Universidad de Kansas. El doctor Soberón fue secretario ejecutivo de la Comisión Nacional para el Conocimiento y Uso de la Biodiversidad, CONABIO, en México, por más de una década y participó activamente en cuestiones de política y diplomacia en relación con la biodiversidad. Es autor de más de 70 publicaciones sobre conservación de la biodiversidad marina y terrestre y actualmente dedica sus investigaciones a la descripción y modelación de la biodiversidad a escala geográfica. Y al último dejamos a la dama, la profesora Christy L. Ibay, quien es consultora independiente de las firmas ESS y LSC. Christy ha sido autora prominente del capítulo sobre salud humana del 4º informe de evaluación del panel intergubernamental sobre el cambio climático y también del apartado sobre la salud humana de la evaluación y síntesis publicado por el gobierno de los Estados Unidos. Ha trabajado para la Organización Mundial de la Salud y con el Programa de las Naciones Unidas para el Desarrollo. Ella se especializa en el estudio de fenómenos climáticos extremos, el estrés térmico, enfermedades transmitidas por alimentos y otros vectores y política de adaptación al cambio climático. Hecha esta presentación, entonces cedemos el espacio al doctor Gordon McBean.
Well, good afternoon, everyone. I'm very pleased to be here. I understand in the presentation this morning from Professor Homer Dixon, you heard a fair amount about climate change. As we've just agreed, we'll talk in less than 12 minutes. So I would like to proceed. What I was asked to do was talk about the challenges of climate change for North America between now and 2030. So if we just look, first of all, of course, the climate is changing, and what I wanted to emphasize is that over the last 50 years, the rate of climate change has been about 0.13 degrees C per decade. Over the last 25 years, it has increased to 0.18 degrees C per decade. So the climate is changing, and it is changing more dramatically than it used to. The IPCC says the warming of the climate system is unequivocal, and at least 3 of us at this table were co-authors of the IPCC reports. Maybe all 4 of us, I'm not sure. Anyway, we are seeing climate change, and we, humans, are most of the cause. We have seen in the assessment of the IPCC changes of the climate impacts in North America, things such as, if I can, yes, it works, the spruce budworm in parts of Canada, the changing of dates, the changing of the amount of forest areas, the relative sea level, etc. These are changes that are influencing our natural ecosystems as well as directly and indirectly on humans. I work on natural hazards around the world, and I just wanted to emphasize that if we define a disaster as an incident where a community is, let's say, overwhelmed such they need outside assistance, the number of such events has increased from roughly 50 per year in the 1960s to almost 1 per day in this century. This is partially due to the increased number of extreme events, but also due to growing numbers of people, the fragility of our infrastructure, the relative levels of poverty, etc., around the world. But if we look at all those hazards, we find that floods, storms, and droughts create more than 75% of the disasters around the world, and those are related to our climate, and as our climate changes, the characteristics of these kind of hazards will change. So if we look to the future, I just wanted to gain out of the IPCC report stress that as I've said, we've had warming of 0.13 degrees C, increasing to 0.18, and for the period roughly through to 2030, the climate projections is that we will continue to warm at a rate slightly higher than we have recently, perhaps around 0.2 degrees C per decade, and it is only later that as we start to adopt emission reduction strategies that we will make a difference between going along this curve, this curve, this curve, or some other possible curve. So we could end up with warming by the end of the century on these scenarios of 1.8, 2.8, or 3.6 degrees Celsius. But I'd like to also emphasize there is a still significant amount of scientific uncertainty on a global basis, and when you then start looking at a regional basis or down to a community basis, there is still a fair amount of uncertainty as to what this change actually means for a community, an ecosystem, etc. When we talk about responding to climate change, I think we need to think about it in 3 different ways. First of all is reducing emissions so that we, instead of following, for example, that curve or that curve, reducing emissions will make a huge difference. And how much we reduce emissions will, by the end, starting now, but in terms of by the impacts by the end of the century, is very different in terms of the total amount of temperature change. We also need to recognize the reality that the climate is already changing and have adaptation strategies. And I guess as I will later get to some comments on where I think we need to go, it would seem to me appropriate that between the countries represented here in North America, there be some collaboration, cooperation, working together on strategies for reducing emissions and also for adaptation. We also need to reduce the scientific uncertainty, and again, working together internationally makes sense. So national and international strategies addressing these issues of emission reductions, adaptation, and scientific uncertainty. So what will our climate look like in the decades to come? First of all, when we do talk about global temperature change, we have to recognize that no one lives at the global average. It will vary around the globe. And in North America, here on the annual basis, or particularly in the winter, we will see, for example, much warmer winters. And over most of the northern part of the continent, increased precipitation in the wintertime, but over Mexico and the southern areas, we will see reduced precipitation. So we have these changes in precipitation. We will also see in the summertime, instead of being the biggest warming at high latitudes, the biggest warming will be over the continental interiors, and that coupled with reduced rain in this area here, these two things will lead to huge concerns about water stress. Both hotter conditions, more evaporation, and less rain falling, considerable issues of water problems, and one of my colleagues, I think, is going to talk about water more specifically. But this does have implications for our whole management of water systems, our sewage systems. Where do we put agricultural investments? Where do we make conscious choices to withdraw possibly from agriculture? Implications for forestry, for floods, for droughts. I was asked to speak about the Arctic region, and I'll just very quickly summarize a few comments from the Arctic. It has clearly been identified by the IPCC as one of the most vulnerable areas on the planet. The changing ice, the changing ecosystems in the Arctic make it, along with small island states and some other things, among the most vulnerable. We are already seeing ongoing impacts of climate change on terrestrial and freshwater species, on communities and ecosystems, and this will continue in the future as the climate continues to warm. Particularly of concern is the impacts on the cryosphere. That's our permafrost. In much of the Canadian North and in Alaska, winter roads are on ice. Structures are built on the permafrost, and as that melts, there will be collapse of some of those systems, the necessity perhaps of moving some of these even whole villages from one place to another, which has already been discussed in Shikmaranov in Alaska. These will have impacts on Arctic human activities. The Canadian Inuit community, or the Inuit Circumpolar Conference, a collection of people of the north around in the northern countries, have already expressed their great concern about this. One of the big issues is the loss of sea ice. We have seen a dramatic decrease in sea ice in the last couple of years, 2006, 2007. We don't know whether this is a new trend or is this just a one-time variation, and we will continue. So the big question is, when will the sea ice disappear? In a decade, in many decades, or by the end of the century? I don't think we know, but all evidence is it will come sooner than we perhaps previously thought. That has major implications. Another issue of concern is sea level rise. The projections made in the year 2000 were that we would follow along these various lines. This was the most likely estimate, the lower limit, the upper limit. If we now put the observations on, we find that we are following along the upper limit. In other words, sea level is rising faster than we would have thought as the warming and the increased melting of large glaciers, land-based glaciers. Implications for many coastal communities, the addition of some more severe storms and storm surges make it, let's say, a somewhat depressing story. If we look at North America, I guess one of the things that is very clear in the IPCC reports is that we have already experienced severe economic damage. We have vulnerability, and the effectiveness and the timing of adaptation is quite varied across our North American continent. Some areas are well equipped and other areas not well equipped in terms of coping capacity and capacity to adapt. I think we need to be addressing that collectively. One of the issues which in Canada we need to be concerned about is, and everywhere else, is the number of hot days. I come from London, Canada, which is on the Thames River. It's just another version of the Thames. Anyway, what we see there is that whereas previously we get about 8 to 10 hot days per year, by the middle of the century we'll have as many as 30 hot days per year. That's over 30 degrees Celsius. The IPCC is saying that these hot spells are virtually certain, or warm spells, sorry, very likely, hot days virtually certain. And that means, if we look at some of the IPCC comments, we need increased investments in countermeasures for hot temperatures and extreme weather because they will have health impacts. And I think Christy's going to talk about that later, so I'll pass on to that. But just stress, health is a major concern here. Our natural ecosystems, as mapped out today, are there primarily because of our temperature and precipitation patterns in Canada. And as we change the climate to the decade of the future, say the middle of the century, those climate patterns will have moved. The ecosystems will not necessarily have moved. So whereas here we have the boreal forest, defined primarily by combination of temperature, precipitation, and soils, by, say, 2050 or so, the climate for that ecosystem will be up here, but the trees will probably still be back where they were. The result is the trees will be less productive, they will be more susceptible to insects, more susceptible to droughts. Many Canadian communities, including ones that my own grandchildren were born in, are forest-based resource communities. Those communities, as they see their forest resources being changed by this, need to worry about economics and other things. So we also have to worry about the increased drought conditions, which I've already mentioned, the southern prairies, which are already in drought-like conditions that will be more prevalent in the decades to come. So the climate change will constrain North America's over-allocated water resources. We're having increasing competition among agricultural, municipal, and other sectors, and we need to worry about that. So I just wanted to show you one dramatic event. This was one rainstorm in August 19th, 2005 in Toronto, cost the Canadian insurance companies $500 million in payouts. They didn't like it. And those kind of events will continue. I just wanted to very quickly, and I think I'm probably already running out of time, but let me just say that, and I think Homer Dixon talked a bit about this, the Climate Convention says that countries of the world are going to prevent dangerous anthropogenic interference. The European Union collectively agreed the target was 2 degrees Celsius warming. What we are seeing, though, is that the 2 degrees C warming target is not one that science is now supporting. If anything, it needs to be lower. How much lower is a question yet of debate and scientific interpretation, and I think it's important that North America's governments have an opinion on that. I won't go into this one, but just to say again, another recent study, and the various studies by Perry, by Hansen, proposing new targets of, say, 400 to 470, or even as low as 350. A 350 target would require very significant and quite quick soon in terms of emission reductions. For those of you who read the Canadian newspapers, there's a story this morning. I happen to be the instigator of a letter to all our government leaders in Canada saying that we think there needs to be, let's say, as we say at the bottom here, sincerely hope that our political leaders will display the urgency and determination that we believe is required. It was signed, in fact, by 130 Canadian climate scientists. So, to conclude, just some thoughts. I think one of the things that we need to have some discussion on collectively through the NAFTA partners and things is what would be North America's position, what is dangerous, how does it relate to emissions, what is the vulnerability, how can we develop adaptation strategies that have some coherence and collection across the continent, the investments in countermeasures, and so, as I said, North American strategies in these areas. And I'll conclude just by thanking you for your attention and inviting the next speaker, I guess. So, thank you very much.